My name is John Biddle. I'm professor of mechanical engineering at Cal Poly Pomona University. I've been here going on my 45th year now, and I teach in the thermal science area in mechanical engineering. Yes, fluid mechanics in engineering is a course that we teach in the junior year, and it builds on courses like math and physics and also dynamics, and it's a course which is required to move on to other courses. It's kind of a bridge course from sophomore level to senior level. In our fluid mechanics courses, students typically start off by looking at fluid statics, and then we move on to fluid dynamics. We look at the control volume approach to that solution, and we also investigate the differential approach to fluid dynamics. Fluid mechanics feeds into many other courses which require a background in fluid mechanics. And so they have to learn these skills to move on to other courses. There's building from dynamics, there's building from physics, and they have to build on those concepts in fluid mechanics and then use them for solutions to problems in the real world. I've taught this course probably over 75 times now. Yes, things have changed dramatically in that time, but they haven't changed all that dramatically, because I can pull out a textbook that I taught out of 40 years ago and the textbook I teach out of right now. And the same equations are in those textbooks, both of them. The same material is being taught to our students now as we have in the past. What's changed then? Handheld calculators, laptops, PCs, desktops. Oh yes, the software with those. How do you solve the problems has changed dramatically. And so that makes the student's life easier than it was in the past. But of course, in an introductory fluids course, we focus on the basic understanding of the concepts and equations, but it's the modeling and the basic equations that we focus on. The most challenging subject matter in fluid mechanics typically is when you get to modeling a real-world problem. It's the mathematical modeling that the students have a problem with, as well as sometimes the assumptions they must make to find a solution to that mathematical model. I find it very useful if I can involve them in their everyday life. So, for instance, in fluid mechanics, we might talk about your automotive radiator, parallel flow in pipes. So I try and bring those real-world examples into class to kind of lighten up some of the heavy-duty mathematical modeling they must do. You've made a great choice in a major. Engineering is a fascinating career, but it's a challenging career. And as a student now, compared to when I went to undergraduate school, you've got many balls to juggle. So you have to juggle those balls and decide where to spend your time. But if you want to be a successful student, number one, you want your degree in a timely fashion. So what you've got to do is put your blinders on and look at that degree and say, I want that degree. And focus on that and immerse yourself. Immerse yourself in your degree. And if you do that, hopefully you'll be successful. If you're in a particular class, like let's say fluid mechanics, every day you go in is a different topic. And if any one day you're taking classes, maybe your first class is fluid mechanics, then maybe thermodynamics, and then maybe stress analysis. You have to shift gears in every one of those three classes and suddenly learn new material in that class. Well, when you get out with your degree and get a job, life does not change. Every day, you're going to have new material thrown at you. You have to absorb that material and find out how to use it to get a solution. So, one of the main things that we hopefully train you as a student, when you leave here, you've been taught how to learn new material. So that's what you should leave with. And because your career will change with time, There'll always be new things to go out there and find and do. So focus on how to learn new material and apply it to a solution.